Microwave ovens work almost like magic. They cook your food without any external heat and with good uniformity compared to conventional methods. But how are they able to do it? And despite their advantages, some are worried about health hazards due to electromagnetic radiation. Will the microwaves cause you any harm? We will find answers to all these questions in this video. So let's get into it. It may amaze you to learn that the invention of the microwave oven was accidental. The scientist, Percy Spencer, was performing experiments on a device called a magnetron. Magnetrons generate powerful microwave radiation. During the experiment, he observed that the candy bar in his pocket was completely melted. That's when it occurred to him to explore the applications of microwaves in cooking food. From this experiment, it was observed that a high-powered traveling microwave has the capability of heating food. But of course, this raises the question of what was in the microwave that melted the candy bar. Microwaves are electromagnetic waves in a particular spectrum. Like any other electromagnetic waves, they have oscillating electric and magnetic fields. If you track amplitude of the wave in a specific area, you can observe this oscillation. In the chocolate melting accident case, the oscillating electric field component of the electromagnetic wave is responsible for cooking the food. Now, let's see how these oscillating electric fields cook food. Most of the food that we consume has water in it. Water is a polar molecule. The hydrogen atoms of the water molecule are placed at an angle of 104 degrees from each other, and both the hydrogen and oxygen atoms have charges. This makes the water molecule behave like a dipole. When an electric field is applied to the water molecule, it starts to rotate due to the torque produced on the dipole. Since in electromagnetic waves the electric field oscillates continually, the water molecules will keep on oscillating. Due to this oscillating rotation, the molecules rub against each other and produce friction and heat in the food. Now, let's look at how to convert this heat generation concept into a workable product. To use the electromagnetic wave's energy efficiently, it must be reused several times. An efficient way of achieving this is to reflect it and keep it confined in a particular area. The best way of making this reflector is with the help of metal. The metallic surface causes the microwave to reflect from its surface, and if you keep one more reflector at the source side, the reflection will keep on continuing. This way, we will be able to trap the energy of electromagnetic radiation within a volume. However, the most efficient way of trapping electromagnetic wave energy is by use of a technique called resonance cavity. This method also increases the intensity of electromagnetic waves. Let's understand the concept of resonance cavity using a simplified approach of standing waves. A standing wave is a stationary wave that fluctuates in time but does not propagate in space. Just by observing these two wave animations, you can understand how a standing wave is different from a normal traveling wave. It is formed when two waves having the same amplitude and the same frequency, moving in opposite directions, are superimposed on each other. Please have a look at these two electromagnetic waves, which are traveling in the opposite direction. Let's pause the animation here. You can see that the waves have 180 phase differences here. When you add both the electromagnetic waves, they will perfectly cancel. Now let's pause at this instant. The resultant is a bigger sinusoidal curve. Let's pause at one more instance. Here you are getting an even bigger sinusoidal wave as the output. By comparing the results of these three instances, it is clear that the resultant electromagnetic wave just oscillates in its position without traveling. Let's examine how to produce two oppositely traveling waves practically. We will get a clear solution for this if we understand how electromagnetic waves get reflected on a metal surface. We know that when a wave meets a reflector, it returns to its source. Can you spot any connection between this reflected and incident wave? The reflected wave is, in fact, the wave that would have traveled forward if there were no reflector. First, of course, you have to fold this imaginary part 180 degrees, as shown. Now, let's add one more reflector, this time at the side of the source. This will reflect the same way again and produce a third wave, and this process will repeat. However, if you keep the second reflector at the intersection point of the first and second waves, the third wave produced after the reflection will be the same as the first wave. This is a clever arrangement. When you arrange the second reflector this way, we will see only two waves traveling in opposite directions, instead of many reflected waves and chaos. If you find out the resultant of them, it will be a standing wave. This is a well-known fact. The standing waves get produced when the distance between the source and reflector is an integer multiple of half wavelength. Thus, the dimensions of the closed structure are determined by the wavelength of these waves. Now, a fun fact. Just measure the cavity length of the microwave oven in your kitchen. It will be an integer multiple of this wavelength. It is clear from this visual that some points of the standing wave are at high energy intensity, and some other points are at zero intensity. Due to this, there would be many spots in a microwave, some cold and others hot. Using cheese, you can demonstrate these cold and hot spots of your kitchen's microwave oven. Just keep the shredded cheese inside your microwave oven for 1 minute. What you see after 1 minute is the cheese surface with a few hot spots. The presence of such hot spots causes a microwave to cook food unevenly. In short, the cavity resonance technique we use to trap the microwaves more efficiently has led to creation of cold and hot spots. To overcome this problem nowadays, a microwave consists of a rotating plate which helps the food cook evenly. The component responsible for producing microwaves is known as a magnetron. A magnetron emits microwaves in all directions. To confine the wave to propagate in one dimension, the magnetron is attached to the waveguide. From the waveguide, the waves come into the cooking chamber to heat food. Another question that has to be answered is whether microwaves are the only electromagnetic waves capable of heating food, or if there are any other waves that could accomplish the same result. Any electromagnetic waves have the capability to heat food, but they come with certain limitations. Waves with long wavelengths can easily pass through our food so that they won't be able to transfer much energy to it. Additionally, to get standing wave, large devices would be required. Shorter wavelength waves are absorbed more rapidly on the outer surface of the food, so they do not penetrate far enough down to cook it evenly. If we want to cook deeply, we have to switch to a very high power source that would be unfeasible. In the microwave range, the suitable frequency for all practical purposes and which did not require a license was 2.45 GHz. The powerful microwaves produced by an oven can be hazardous to humans if we come in direct contact with them. But don't worry, the electromagnetic radiation produced by a microwave oven is always confined within it. It will never leave the chamber. So there is no point in worrying about the health hazards caused by the electromagnetic radiation of microwave ovens. Now the most interesting question. Why is heating with a microwave oven superior to conventional heating methods? Since microwaves can penetrate the food is cooked from the inside, slowly cooking at the surface. Moreover, it cooks food faster than other conventional methods. The convection method cooks food from the outside in as opposed to the inside out. This is because the heat energy has to travel from outside to inside, but this method can be useful on some occasions. When you need food with a crisp surface and a soft interior or baking, the convection heating method is preferred. Due to this reason, modern microwave ovens come with a convection option for baking purposes. We hope you got a complete understanding of the physics of microwave ovens. Please don't forget to be a part of the Licse team before you leave. Thank you.